Hello, PreCalc. For those of you who were absent the day we went over the Ambiguous case project, I just want to go over the highlights for you. You are going to draw everything with a compass, ruler, and protractor. All of your calculations are done with the calculator on a separate sheet of paper, and you will just summarize here on this sheet what those numbers are. When, however, you draw the triangles, you will need to do so with the tools. The tools are a ruler, a protractor, and a handy-dandy compass. And if you don't have any, you need to come into tutorial, borrow them, get it done. The way that you are going to do this is you are going to draw a side of your triangle, the one that you do not know how long it is. So just make it nice and long with a ruler. The first thing that you're going to want to do is measure the given angle. So for problem number 1, the given angle was 20 degrees. Line up your protractor with the dot at the end of the line and then measure out 20 degrees. Make a dot, connect the dots, and we will measure that in a minute. This is the given angle. It doesn't matter if it's angle A, angle B, angle C. However, for problem number 1, we were given that this is angle A. The side opposite the given angle is going to be the one that goes on the compass. So in this example, that is going to be the 4 inches, which means that this is going to be side B. Side B was given as 3 inches, and we need to measure that with our ruler. Make a mark, and then we can erase this extra. Side A is 4 inches. That's what we're going to measure on the compass. So you're going to take your ruler and you're going to open your compass nice and big so that it is 4 inches on the radius of the compass. So mine barely fits. Hopefully an easier one to move. That looks like it's about 4 inches. You're going to put the point right here, and you are going to make an arc. Leave your arc marks, do not erase them. You're going to intersect this nice long line, which you don't know how long it is, in 2 different locations if you can. So it's here, and when you swing this around to the other side, you will see that it is past angle A, which means that if it connects with this line, it's no longer using angle A because it's outside of the triangle, which means physically there is only one triangle. And there is one triangle. This intersection point needs to be connected. Opposite side B is angle B. We are going to measure this with the protractor, with the ruler, and with the ruler here. This is angle C, and we're going to measure this with the protractor also because it's unknown. Okay, so the last things we need to do, this was given, it was supposed to be 4 inches, but you know, it's not always perfect. In this case, it actually looks okay. This is 4 inches. This was given side A. And then this side here is 6 inches, and that's a half. That's a quarter. And maybe it's 4 quarters, 5 quarters. No, sorry, this is a half. These are quarters, so that's 4/8. That's a half, 5/8. So 6, 5/8. If you use your calculator to figure out what 5/8 is, 5 divided by 8 is 0.625. So this is essentially 6.625. If you look at your calculations, you would have gotten 6.7. Those are allowed to have a difference, and in fact, they should. If you write 6.7 here, you will not get full credit because that tells me you didn't actually measure it with a ruler. This angle needs to be measured. It is 10, 15, maybe 15.5 degrees. It's actually pretty hard to be that accurate, but I'm going to call it 15.5 degrees. For your project, you'll hopefully put it inside, make it look a little bit nicer. And then this last angle, angle C, is 145 degrees, I would say. Now, angles may not add up exactly to 180, and that's okay. It's because we have measurement error with our tools. If we compare again to the actual answers for problem 1 that we got with the calculator, 15.5 degrees for angle B, the calculator will give everyone 14.9. You may not get 15.5, you might get 15 degrees, but there's no way that your eye can tell 0.9 and a 0.1 difference. So it needs to be something, when I look at it, I say, okay, yeah, that's possible to figure out a half a degree. Angle C is 145. It's calculated as 145.1, rounded to tenths. It says so in the directions. Again, if you put 145.1 here on your project, that tells me that you just copied this answer. You didn't actually measure it with the protractor. And again, with your ruler, we should see 8ths, 16ths, things like that, because that is how we measure in inches. So that's problem number 1. Make sure that you actually label the problems. For your paper, you may use the front and the back of the large paper. Problem number 2. If you use the calculator, you will find that it is a no solution. You still need to draw it. Again, you will start with a nice long line. We do not know how big that is. In this problem, we were given angle B is 42 degrees. So we will measure out 42 degrees, make a dot, connect it. You could measure it again just to see if it's roughly actually 42 degrees because you may have some errors there as well. They also gave us side B. B is 2.5. That is what is going to go on the compass over here. So they gave us another side, which is C. C is 4 inches. We're going to measure that out and mark it. Erase. Take the compass and put side B, opposite angle B, opposite the given angle goes on the compass. We are putting side B on the compass at 2.5 inches. That's 2.5. That is roughly this. You put it at the end of this 4 inches, and when you draw your radius, you will see that there is no triangle formed because if you put the side here, or even at a right angle would be the shortest distance, it does not reach the other side. And so even though it's a no solution, you have to draw the triangle. And the side that was given here, C, would create angle C over here, which means that this is angle A. In this problem, the only other thing that you can measure here is the 2.5 inches. You cannot measure this side. You cannot measure any additional angles because nothing's given to you. So number 2 and number 5 are no solution, and those should actually be the easiest ones to draw. Last but not least, I'm going to do problem number 3. Again, with number 3, we're going to start with a nice long line. You should know that there are 2 solutions to number 3 because there were 2 blanks. with triangle spaces. These are the actual calculations with the calculator. What was given is angle B is 25 degrees. That is where we are going to start. I'm going to put a dot here and measure 25 degrees. Label your points, label everything that you do. Opposite B will be 3 inches. That's going to be on the compass. The next side that was given is 4 inches, and these are all angle side, so the next thing we're going to do is draw this side correctly. It's 4 inches right here. Erase. Only thing you don't erase are your compass marks. Side B is 3 inches. Open your compass again. To 3 inches. And here's the magic, folks. When you put the point here, you intersect this line. This is going to be the first point, the first triangle. If you flip the compass over without moving the compass setting, you'll see it intersects the line one additional time, which actually includes angle B still. It's not past angle B, which means there are 2 triangles here. First, if we connect, this is the first triangle, so this will be A1. It's opposite side A. That means this is C, or from here to here is C1. And we can measure this, but it is approximately 3 inches. Maybe it's 15/16. So again, it's not actually what was given, but it's close enough. This from B to A1 will be the first side C that you'll measure and write down. And the second triangle, one inside the other, I think my point is kind of bad here, is to this location here. So the better you make your points, the more accurate you'll be. This will be location A2, so angle A2 will be this angle here. This side and this side were on the compass, which means they are congruent, which means that this angle is A1 because of isosceles triangle theorem. You can see that A1 plus A2 equals 180 degrees. And that's how you can solve it when you're doing it with a calculator. However, you are going to measure with the protractor these angles. So this triangle here is the second triangle. I'm going to highlight it for you. The highlighter. So that's triangle 2. This is problem number 3 again. And triangle 1 is the big one on the outside. When I measure angle A1, I can see it's about 35 degrees, maybe a tiny bit more, but I can't really tell. And then I'm not just going to subtract from 180, I'm actually going to measure A2, which looks to me as if it is 145 degrees approximately. And again, those might not be exactly what my calculations are. 35 and 145 are a little bit off, but again, this is with the calculator. This is by hand. And again, you're going to measure from here to here is 1 and 3/16, maybe, for C2. Angle C2 is just this little angle here. C1 is this whole angle here. So C1, side C1 is 6 and 1/16. And then I'll let you measure those two. But again, this is 6 and 1/16 is maybe a little less than 0.1. 1 and 3/16, might be a little bit more than 1.1. But again, that's all just error which is expected. I'm not going to do the other 3 triangles, but it's the same idea. Number 4, though, is a 30, 60, 90, which means there really is only one triangle. You should know that by the number of blanks there are anyway. And again, number 5 is a no triangle, a no solution, but you still draw it. And number 6, there is a triangle. Good luck, and remember it's due on the 5th/6th of 2018.